Welcome to Bot Thoughts by AmtocSoft. I'm Alex, and Sam is here with me today. We're talking about cloud architecture, specifically the shift that's been happening over the last 2 years where the monolithic public cloud-only strategy is breaking down. Terms like hybrid cloud, multi-cloud, and sovereign cloud are everywhere, and I think a lot of people nod along without really understanding what they mean in practice. Sam, let's ground this. What's actually driving companies to rethink their cloud strategy right now?
Three forces are converging simultaneously. First, cost repatriation. For several years, the assumption was that cloud is always cheaper than on-prem. That's been disproven at scale. Companies that moved everything to Oz or Azure in the early cloud wave and then scaled up found that their cloud bills grew faster than their revenue. A 2019 Andreessen Horowitz analysis estimated that the top 10 cloud-intensive public companies could save approximately $4 billion in combined market cap by moving 50% of their workloads back to owned or co-location infrastructure. That kicked off a wave of what's called repatriation, bringing select workloads back on premises. Second, regulatory pressure. GDPR in Europe, the EU AI Act, and similar legislation in other jurisdictions are creating hard requirements about where data lives and who can access it. Storing European personal data in a US-owned data center is legally complicated in ways it wasn't 5 years ago. Third, AI infrastructure. Training and serving large models requires specialized hardware, H100s, A100s, that isn't always available in the public cloud at acceptable cost or latency. Some organizations are buying their own GPU clusters and building private AI infrastructure.
Define hybrid cloud properly for me, because I think people use it to mean very different things.
Hybrid cloud, properly defined, means a unified architecture that spans private infrastructure, your data center or co-location, and one or more public clouds with a consistent control plane across all of it. The critical word is unified. Hybrid is not just, we have some servers on-prem and some on Oz. That's just a mixed environment. True hybrid means you can deploy a workload, manage its lifecycle, monitor it, and scale it using the same tooling and the same abstractions regardless of whether it's running on-prem or in the cloud. The tooling that enables this, AWS Outposts, Azure Arc, Google Anthos, Red Hat OpenShift. These products extend the cloud provider's control plane to your on-premises hardware. You manage your on-prem servers from the AWS console the same way you manage EC2 instances. The private infrastructure looks like cloud infrastructure to your platform team.
And multi-cloud is different from hybrid cloud. They're often used interchangeably.
They're related but distinct. Multi-cloud means using more than one public cloud provider, Oz plus Azure plus GCP, for example. Hybrid cloud is about public plus private. You can have one without the other. You can run on AWS plus GCP with no private infrastructure. That's multi-cloud but not hybrid. You can run on-prem plus a single public cloud. That's hybrid but not multi-cloud. And you can run on-prem plus multiple public clouds. That's both. Multi-cloud adoption is usually driven by one of three things: avoiding vendor lock-in on specific services, using best-of-breed services from different providers, or satisfying geographic redundancy requirements that a single cloud can't meet. The operational cost of true multi-cloud is significant. Your teams need to understand multiple providers' IAM systems, networking models, and service interfaces. Most companies that describe themselves as multi-cloud are actually using AWS for 90% of their workloads and Azure for Microsoft 365 integrations. That's not really multi-cloud strategy, it's cloud sprawl.
Sovereign cloud is a newer term. What's that about?
Sovereign cloud is the response to a specific regulatory and geopolitical concern. What happens when a foreign government can compel access to data stored in a cloud run by a foreign company? The U.S. Cloud Act, passed in 2018, allows American law enforcement to compel U.S.-based cloud providers to hand over data stored anywhere in the world, even if that data belongs to a European citizen stored in a European data center. For European governments, healthcare providers, and financial institutions, that's unacceptable. Sovereign cloud means cloud infrastructure where the sovereign, a national government or an approved local entity, maintains control over the encryption keys, the data, and the legal jurisdiction. Microsoft Azure has sovereign cloud regions operated by local partners in France, Germany, and the EU. Oz has Gov Cloud. Google has Google Cloud Sovereign. The practical architecture. Data never leaves the sovereign boundary. The cloud provider cannot access the data without the customer's encryption keys, and the operational staff who can touch the infrastructure are all local citizens cleared to the appropriate level.
You mentioned control planes. That's the key architectural concept here, a unified control plane. What does that actually look like in practice?
A control plane is the system that manages your infrastructure. It decides where workloads run, scales them up and down, enforces policies, provides the API that your platform team interacts with. In a traditional single cloud setup, the control plane is AWS or Azure. In a hybrid or multi-cloud setup, you need a control plane that can manage resources across multiple environments. The leading approach is Kubernetes plus a policy overlay. Kubernetes abstracts compute into a consistent API regardless of whether the underlying machines are on Oz, GCP, on-prem, or edge locations. Tools like Crossplane extend Kubernetes to also manage cloud infrastructure, databases, queues, storage buckets, through the same Kubernetes API. For policy enforcement, Open Policy Agent or Kyverno sits across all environments enforcing consistent rules. Which images can be deployed, which namespaces can talk to which services, which data classification levels are allowed on which infrastructure. The vision is that your developer submits a workload definition, and the control plane decides where to run it based on cost, latency, data residency requirements, and capacity, without the developer knowing or caring about the underlying infrastructure.
How do you actually model the costs for this? Because cloud bills are already hard to understand, and adding on-prem and multi-cloud makes it even harder.
Cost modeling in hybrid and multi-cloud environments is genuinely one of the hardest operational problems in platform engineering right now. The fundamental issue is that public cloud and on-prem have completely different cost structures. Public cloud is variable cost. You pay per compute hour, and the cost scales with usage. On-prem is mostly capital cost. You pay up front for hardware, and then have relatively flat operational costs over the hardware's lifetime. Comparing them requires modeling your workload's utilization curve over time. The break-even point for owning versus renting compute typically sits between 40 and 60% average utilization. Below 40% utilization, cloud is usually cheaper because you're not paying for idle capacity. Above 60% utilization, owned infrastructure typically becomes more cost-effective because you've amortized the capital cost over sufficient workload. Tools like Cloudability, Cloud Zero, and the open-source OpenCost project provide unified cost visibility across clouds. For on-prem cost attribution, you have to build that yourself, allocating hardware depreciation, power, cooling, and data center space to individual workloads.
Networking across all these environments seems like it could be a nightmare. Private connectivity, latency, security.
Networking is the hardest part of hybrid and multi-cloud architecture. Every environment has its own IP address space, its own firewall rules, its own concepts of private and public routing. The standard approaches for inter-environment connectivity, AWS Direct Connect or Azure ExpressRoute for dedicated private links from your data center to the cloud. These give you private bandwidth with predictable latency rather than going over the public internet. For multi-cloud, cross-cloud dedicated links from providers like Megaport or Equinix Fabric connect cloud environments at colocation facilities. For the software layer, service meshes like Istio or Consul extend across environments and provide MTLS encryption, service discovery, and traffic policies across the entire fleet, regardless of where individual services run. The emerging pattern is SASE, Secure Access Service Edge, which combines SD-WAN, Zero Trust Network Access, and cloud-based security inspection into a single service that handles networking policy consistently across all environments. Vendors like Cloudflare Zero Trust and Zscaler are building in this space.
For an engineering team that's all in on AWS right now, where does a hybrid or multi-cloud conversation even start?
Start with workload classification, not with architecture. Audit every workload you run and categorize it on two axes: data sensitivity and utilization pattern. High utilization, low sensitivity database servers, compute-heavy batch jobs are the candidates for on-prem or colo repatriation. High sensitivity, PII, payment data, regulated health data, are the candidates for sovereign or private infrastructure if you have regulatory requirements. Bursty, low average utilization, seasonal traffic spikes, CI/CD build workers, these stay in public cloud because the elasticity value justifies the cost. Once you have that classification, you'll see naturally which workloads make sense to move and which should stay. Start by moving one low-risk, high-utilization workload on-prem and running it for 6 months. Measure the actual cost versus what you were spending in the cloud. That real data is infinitely more valuable than any theoretical cost model, and it builds your team's operational muscle for managing hybrid infrastructure before you have a dozen critical workloads depending on it.
3 takeaways for engineering leaders thinking about this.
First, cloud is not binary. All cloud or all on-prem are both probably wrong for your organization at scale. The question is which workloads belong where, and that answer changes as your utilization grows and your regulatory environment evolves. Second, the control plane investment is the foundation. Before you can run workloads across multiple environments reliably, you need a unified way to deploy, monitor, and manage them. Invest in Kubernetes or an equivalent abstraction before you spread workloads across environments. Running workloads in 3 places without a unified control plane is not a strategy, it's technical debt accumulation. Third, data gravity is the single biggest constraint in any migration. Workloads follow their data. If your database is in AWS, moving the application layer on-prem introduces network latency between app and database that can dominate query performance. Plan your data placement first, then plan your compute placement around it. Every organization that's tried to move compute while leaving data in place discovers this constraint the hard way. Full architecture deep dive, including the control plane decision framework and workload classification template, is in our blog post at AmtocSoft.blogspot.com.
Sam, this is one of those conversations where it becomes clear how much complexity is hiding behind terms that everyone uses casually. Hybrid cloud, multi-cloud, sovereign cloud, they each mean something specific, and conflating them leads to expensive mistakes. For everyone listening, the blog post goes deep on the workload classification framework, the control plane comparison, Azure Arc versus Outposts versus Anthos, and the network architecture patterns. Find it at AmtocSoft.blogspot.com. Subscribe on YouTube or wherever you get your podcasts, and support the show at buymecoffee.com/AmtocSoft. I'm Alex, Sam's been Sam, and this is Bot Thoughts. See you next time.